Hello everyone, are you able to hear me clearly? Hi Lakshman, hi Lloyd, hello Sanjay, hi, hello Sarvana. Alright, so should we start now? Hello Vidya, hi Suresh, hi Sandeep, hi Joshi. Should we start now? Alright, great. So till the last time, we discussed about, let me just close my Gmail. Alright, so where were we till last time? What did we discuss? Alright, we had discussed the joins. I remember that. Limit sample we had discussed. We discussed parallel also. So till what point have we discussed? Alright, so where were we? Do you remember? Till the UDF. Okay. So, alright, I think we had done this, or this was left. Alright, so we at this, let me just go through what all did we discuss. This is an older video. We have to go to this one. Alright, great. So now we are done. All right. So, did you try solving the problems which are located in here, like quiz and subjective quiz? There are two parts. One is subjective, one is objective. Were you able to complete that? Okay, great, great. So Vidya has done. All right. Okay, okay, great. All right, all right. Please finish it. Okay. Try the objective first, Anandita. Okay. So if you're stuck with subjective, try objective a little bit. That'll give you quick, you know, refresher of the course, and then you can attempt the subjective. Although the subjective is mentioned above the objective, but you can try the objective first. This is the objective one. Okay. All right. Okay. Okay. Please get it done. Please do finish this. All right. So, did anybody try to create UDF by themselves? Not yet. So let's log in into Hadoop 3. Hadoop 3 as what is our login? Our login is 17. All right. So pig UDF, I think we have already tried. Right? Not yet. All right. Anyway, we will just go through once more. So I think we just left at this screen where, so were we able to, quick question to all, I'm not able to recollect if we were able to run it till the end, as in were we able to actually execute a pig UDF that we created? Lloyd, Lakshman, till the end, did we discuss everything? So this was the UDF which we were planning to do. All right. Yeah, I think we did. We did till the end. All right. All right. Good. So do you have any questions before we move forward? Till now, we have almost covered the main operations which are part of pig Latin and pig, including all kinds of joins, loading the data, and UDFs, and various kinds of operations. So, do you have any questions before we move forward? Okay, Savna has questions in all parts. Please feel free to ask those questions. So, Savna, if you have questions related to pig, we can discuss them today. Okay. And rest of the questions you have, we can discuss it over the forum. You can go to the forum and ask the questions. We will all try to answer those questions. All right. That will be beneficial to all of us. You can click on the forum and then ask. If it's a general question, okay. If it has to do something very specific, support related, then ask on the support. All right. So first question is from Sanjay. Let's just create. So the question from Sanjay is, this is, what was the, I think, session number 9. All right. So the first question from Sanjay is, what is the difference between Pig and Hive? They both look SQL compliant. All right. So the problem with SQL is that for SQL, you you need to have a table with clear data types, right? When you define a table, you need to have very clean data types, as in every column has got to have data types, and we need to have a clarity on what is the name of the column and everything. But in case of pig, that is not mandatory, which means that pig can be used for handling unstructured data while SQL cannot be. Okay, so while pig is okay for structured unstructured data, Hive is only for structured data. All right. Next is that pig gives you more control over the the process. Hive gives you more control over the output. Okay. So I mean to say that pig gives you more control over the complete process, because here you are defining step by step. You are not just asking for the end result. Okay. Now, next is that for pig is just a client, while Hive has got a server as well. Okay. All right. So that was Sanjay Tandon's question. Okay. So Lakshman's question is, can you show me how to invoke Java built-in function again? All right. Here is the way you call invoke the Java built-in function. So you define a alias for the actual function, which is this one. Okay. So let's just go over to the terminal as well. And all right, let me take out this terminal from this window so that I can easily switch. All right, let me just, okay. So here we are. So we could launch pig here. And then we can define the function. All right, so the function has been accepted. Next, we can load the data. All right, so the data is in the, all right, so let me just modify it a little bit and say slash data. Okay, and then say this. So we're loading it. And now we want to convert the volume into this. So in hex dot, if we say dump, it will bring the data here. All right. So you can see that it has converted it into hexadecimal, the volume into hexadecimal. You can see that you were successfully able to convert it into hexadecimal. Now, if you want to understand what exactly is going on, what are we doing here is we are using this static function. Let's try to execute it from here. Okay, let's just click create a simple class. Let's say uh, test. Okay, let's say for example, and I say main. All right. Here I can say things like to, so I can say integer dot to hexadecimal, and I can say any number. Okay. If you are from Java background, you'll be able to understand what I'm trying to do. I'm trying to convert this number into hexadecimal, for which what I've done is first I have converted into this string, and then I'm printing that string. Okay, so you can see it's 7b. So invoke for string is used here. If you see, invoke for string is a function provided by pig so that you can invoke any Java static function. All right. Good, Lakshmanan and everybody. Great, great. Let's move on to the other questions. All right. So we were able to successfully execute. All right, not this. Execute our pig, uh, uh, our invocation of any Java static function, which is a part of library. Okay. And as a matter of fact, if you want to just execute an function from outside, you can simply execute it by the way of these commands. Okay. Once you register your jar, you can invoke the static function from that jar as well. Okay. Now there's a question from Sarvana. Okay. So the question is, what is the advantage of pig over MapReduce? Meaning, can there be process which cannot be done? All right. So the answer to the second one is none. So capability wise, MapReduce is definitely more powerful than what pig is, because at the end of day, pig Latin is being converted into MapReduce. Okay, so there'll be everything what a pig Latin can do, MapReduce will be able to do. Otherwise, we will not be able to translate pig Latin into MapReduce internally. Okay. Second question here is, what is the advantage of pig over MapReduce? The main advantage is it's a high level language, high level data oriented, data flow oriented actually, oriented language. Okay, so you don't have to deal with the intricacies of key value pair, and it's less repetitive. Okay, it's less repetitive. We had a discussion on the last time about this. All right, now we go with the next question. Next question is from Anandita. Question is how to count the total number of records in joining two tables. You mean after you have joined two tables, you want to find out how many records are there? All right. You can simply do, there is a count function we had discussed last time that you can utilize in order to get it done. I'll show you that. Okay. So you could use a count function which will basically give you the number of records in any any of the any of the tables, I mean data sets. Okay. So let's say we have just loaded something, right? Let's say in hex. Okay. So we could say count in hex, or there was one more. All right. All right. So yeah, let me have I count in hex. Okay. The one which we had discussed already. So you could say, um, let me just think. So you could say C equals to for each in hex generate count of, say, what was the actual data set we were using. So describe in hex. Describe describe in hex. Yeah, that's correct. Or you could actually simply do for each group in hex all and generate Oh, I have to make it count in capital. That's it. Yeah. All right. So actually, you could simply do things like you could. Oh, this- all right. So we could actually do something very simple. Okay. So we could actually group all of the records and say group divs and say all. Okay. And then we could say group count equals to for each group all generate count, count of. Okay. Okay, we could see what is, and then we could say. All right. So let me describe what I did. Let me take it out of this thing, and then it'll be more clear. All right. So this is what I did just now. Let me. This is what I did. Okay. Looks little lengthy process for all of us. So okay. So the one which we had discussed till now, it always had a group, right? So we could easily generate the number of values for a particular key using the for each, right? Something which we have not discussed yet is you can group all the values of a div by saying all. Okay, so all the values for a column, for all the values for a key in the data set will get grouped together, and you can simply do a count over that. Okay, that's what we did just now. Okay, so it has given us a result of these many records. All right, so we had some data set, this one. We wanted to count number of records. Okay, although counting of the number of the records seems so trivial in almost every system, but it's not so straightforward when we talk about big data. Okay, even in case of your map reduce, you will have to go extra mile to find out the total number of records. Number of lines in the input are something you can predict, but number of record is something you have to count. All right, for example, if you are doing having something, Or we could actually do something like what we could have done in case of MapReduce. In the map, we would just spit one as the key. Okay, that's all. One as the key and the value. And in reduce, we will just sum up all the values. That's how we will count the number of records. Okay, and that's what we are doing here also. Okay, here we could have here instead of using group all, we could have done a projection where we are generating a key as one and some value and then group by that value and then do the count. Okay, so that's what we have done. Is that clear to everyone? Anandita? Okay, all right. Now, Savna's question next is, which of the following best describe the working of text input format? All right. So, okay, let me see if other people are able to answer this. So the question is, which of the following best describe the text input format? Text input format is what we have used for our word count and for almost every text processing. So answer number A is input file splits may cross line breaks. Okay, a line that crosses tile splits is ignored. The input file is split exactly at the line break. So each record, this is definitely not correct, right? Because input file is split because file is not splitted according to the line breaks. File is splitted according to uh, the block size. Okay, so we can completely ignore the second answer. We will further go into the details. Input file split may cross the line breaks. Okay, a line that crosses file splits is read by record reader of both splits containing the broken line. A line that crosses the file split is read by record reader of both splits containing the. This is also not correct. The input file splits may cross the line breaks. Okay. A line that crosses the file splits is read by record reader of the split that contains. This is not correct. This is correct. Okay. Input file. So the way we had discussed, so the line might cross to the next block. Okay, and what we discussed was the second, when two record readers are trying to read, they will keep on skipping till they reach the new line, till they encounter a new line character, right? Therefore therefore this is correct. So input file split may cross line breaks. A line that crosses the file split is read by the record reader of the split that contains the beginning of the broken line, right? So this is what is correct. This is not correct. All right. So this we had discussed. If you go through the session where we were discussing the strategy in which how do actually the record reader work, at that point of time we had discussed this part. All right. That was Sarvana's question. So Anandita's question is, how do we define a tuple bag slash map for a table? Okay. So how do we define a tuple bag slash map for a table? You don't have to define it that way. Okay. So whenever we are loading, say, CSV file, okay, we will be loading it a a bag of tuples, and each tuple represents a row. Each tuple represents a record, and bag represents the table. All right. So Richard's question is, wouldn't the advantage be time since Pig is easier and faster to use? Definitely big yes. Completely agree with that. So Lakshman's question is that we generally encounter that there is something called Apache Tez. Apache Tez. So do we still need to think in terms of MapReduce? Yes. At the end of it, whether you are using Apache Tez also partially uses MapReduce, although it comes with its own processing as well, but it also uses partially the MapReduce. Okay. So, from Sanjay's point, his question is Pig, if Pig is high level, is it slower than MapReduce? So I would say the it will be little slower, maybe maybe few milliseconds, okay, which are consumed in translating, in parsing Pig Latin and converting it into MapReduce. And afterwards, the process will be similar. All right. Great, great. So Vidya was able to guess. Thank you, Vidya. Vidya was able to get that it was answer number E. Great. All right. So these were the discussion on the questions what we had since yesterday last time. Do you have any other questions, or should we move ahead with our today's plan? So Lloyd's question is, can we write the pig output to Hive and HBase directly? Answer is yes. You will see this. Okay. So there is something called HBase catalog. Okay. You could use the way we use pig catalog, pig loader. I think we use loader. There's something called HBase loader. From HBase directly we can write to the from pig you can directly write to HBase. And with respect to Hive, in case of Hive, it's not a big deal because Hive anyway saves everything onto the file system. You can directly write in the file and it will reflect in Hive. Okay. Also, please note that neither Hive nor Pig allows the manipulation of the records which are already stored. You can generate new set of data and store. Okay. Because both of Hive and Pig are analytical tools. Okay. Good. All right, let's move ahead. Great set of questions. So Sarvna, whatever questions you have, let's start asking on the forum here. Okay, and all of you can look at the questions and answer those. Okay, this forum is fairly popular, as in it. If you search for Hadoop forums, it comes on Google's first page or second page. All right, so you can ask your questions here, and we will try to answer all of those. All right, all right, good. Now, if you have some legacy code where you are not able to, you are not able to create the same code in UDF. See, there is a traditional code which is written in Perl and is lying in your organization. And what you want to do over there is you and this Perl code is having your business logic. And that business logic is quite difficult to translate at this point of time. Okay? Or some sort of encoding algorithm or some sort of translation is there in those scripts, and you're not able to translate that into a UDF in Java. So basically, you have some legacy code in some language, and you don't have this luxury of writing or rewriting it in Java. So in those cases also, you can use pig. You can simply pass your tuples through the script. Okay, if this script takes the data from standard input and gives the output to standard output, you can use a pig over it. If it doesn't provide you, it doesn't read from standard input and gives out the data at standard output, you can wrap the existing script in another script and call that from pig. Okay, so something of this sort. So you have this nice Perl file called hidiv.pl, and let's say for this example sake, this hidiv.pl is available in the path, the system path from which the binaries are executed. It's available on all the nodes. Then all you have to do is first you load your data in a particular data set, and then you stream. There is a keyword called stream divs through your hivediv.pl. Okay, now notice the back quotes. These are back quotes, these are not forward quotes. The objective of putting back quotes, as it was a conscious decision from pig, guys. The reason is here you could also supply the arguments, and in case you are having single quote or double quote, you can put those here. Okay, to avoid the confusion with single quote double quote, they have kept backquote, and backquote is the one, if you are on MacBook you will see the backquote just before the key 1. I think on normal keyboard as well, it is just before the key 1. All right, it's not tilde. Tilde looks like this. It's not a single quote. Okay, it's a backquote. So you can stream your data set through a program like this. All right, sometimes you want to have the arguments, as in this PL file accept some sort of arguments. You can do that as well. Also, sometimes this file may not be available already on the nodes. In those cases, you can first define a function called hd. All right, you can define an alias called hd, which says that execute this command. okay, which is hidiv.pl minus r is some argument this program is expecting from you, and then minus r some argument options and the value. So this is the command you would traditionally execute in your organization and pass the data as standard input, and it'll give you the data at standard output. Okay, so in those cases you can very well use this, which also brings us to the reason that, let's say you want to grab some values in a data set. You can use a command called grab here without having to worry about anything. You can simply say stream my data through grab as this, and it will basically grab those records and give you the output. All right, and if the script is not available, if the script is not available on all the nodes, you can say ship and ship the script together with your program. And once you have defined this alias, you can say stream devs through simply hd and as this. These are the values that are going to reach to hd in comma separated format. So Sanjay's question here is good question. Okay, in this example, what is returned in high divs? So basically, high divs prints to the standard output, that is your screen, whatever input it takes from the standard input. That's what is assumed here. And yes, the output can be further passed to another legacy code. All right, good. Now, sometimes there are already many people working on Pig, and they're contributing to the something called piggy bank. Piggy bank is a library of function from other people who are contributing. Okay, and these are basically UDFs, user defined functions, just that the code is available in the public domain. You can simply uh, check out that code and compile it, and then the usual process, the way we had used our own UDF, you can use those UDFs. All right, all right. Now here is a good question from Sarvana. Sarvana says, do we have such PL file existing in our node? No. In if this high div.pl does not exist on all nodes, you can simply say ship ship along with the highdiv.pl. All right. So you just saw here in the previous this one. This makes it possible to take this file and automatically deploy it on all the machines. All right. Does it make sense to you? All right. So that was piggy bank. You can simply check out and start using that. One of the examples in piggy bank would be to basically register, say, check out and register it, and then you can start using the functions provided there. Okay, so something like uppercase, which is an example, just for the heck of example we have provided here. All right, now there is an interesting one more thing called for each nested. All right. When you want to when you want to apply when you want to apply the usual filter for each and the rest of the values inside a record or inside a group, then you can use for each nested. Let's take an example. Let's take an example of such a case. Let's say the problem statement is given a list of given a list containing city name and person's name, find out the count of distinct names in each city. You have to tell distinct names in each city. How would you go about this? Anyone? Yeah? All right. No answers, or is somebody typing? All right. So the way you could do is you can basically, up to here, it should be okay for you, right? We loaded the people from the file called people as city and name, and then we grouped by people, okay? Sorry, grouped people by city, okay? We grouped the people by city. So the way once we group by city, what we'll get is for there will be a key called Bangalore, and then there will be three values: Sandeep, Sandeep, and Vivek. Now our objective is to find out the distinct value. Out of these three, we want to find out the distinct values out of Sandeep, Sandeep, Vivek, and then count. So we can do it very easily by saying for each group and then putting the brackets here. Okay. We are saying after grouping the data for each of the group, find out the distinct name by saying distinct people and then saying generate generate the group and count of distinct names. Okay. So what we just saw after we have put the curly brackets, the values, the list of values is behaving like a data set. So the list of values, we can apply our usual commands such as distinct, count, and maybe we can further apply for each on those records. Okay, we can further apply the for each on people, right? So basically, by putting curly brackets, you get here inside these curly brackets, you will get the list of values for each of the key as a data set on which you can further apply all the other functions. So this is great for processing the complex structured data set and reaching to some conclusions, right? That is how it happens. All right, is it clear to everyone? All right. Next is an interesting example of fragmented joins. So yeah, now Shavna's question is, what is a group? Group is the name of the column which gets generated every time you group your data. Okay, so let's say we have got divs here, right? Divs here. So we can say describe divs. Okay, so and what we did earlier was something like here. We said let's try to group it. We say divs one equals to group divs by exchange. All right. So when we group some data and we say describe divs one, okay. Now you will see describe. Did we make a mistake? Describe. Uh, uh, Describe. Okay. So yeah, you see one more extra column here. When you group something, so automatically one extra column called group gets generated in the output. So divs1 contains an extra column called group, and second column name is divs. And what is divs? Divs is a big object that contains, it's a bag basically. The divs is a bag of tuples, and each tuples are the tuples that belong to this group. Okay. All right. Now here that might look little confusing. So here we are saying, okay. So we are saying group, okay. We are saying group, and then inside the group we are saying for each group. Now inside for each group, what are the things you will get? First thing you will get is the people, okay. The second column will be people, okay. That's what it was, right? That, if you remember our discussion, second column will be people and first column will be group, okay. And that's what it is. So it automatically generated two columns. So grp will contain two columns. You can try this, you can actually try this by loading this data. If you can load this data into hdfs, you can simply try to load it, and then basically try to group it. Once you group it and say describe grp will have two columns. One column name would be group, group. Second column name would be people. And the second column name called people will be a bag. Bag means a collection of tuples. All right. So, and that's what we are doing. So for each group, you will get two things. One is got called people and second is called group. So we are saying distinct people dot name. And second we are saying generate group and count of the D names here. Now, Sarna's question is, what will be the value for group column? Group columns value will be Bangalore and NYC. Yes, that's correct. It is the city in this case. All right. Great set of questions. Did I miss anybody's question? I hope I have not missed. All right, moving on. Now, this is a very interesting part. Let's think about it a bit. Let's say, let us say you are given one big file, one very small file. Okay? One file containing a billion entries of all the people's name and their country's name. Okay? Now, objective is to translate this table into name of the person and country code instead of country name, right? And this name of the country is hardly 100 entries. Okay, so the total number of countries hardly are the data we have is hardly the data is in hundreds, maybe 200 or so, and this other data is billions of entries. Now your objective is to join both of them and generate this result where instead of country we have code. So what will be your approach? And let's think about our usual map reduce or whatever approach you can think of, right? What will be the right approach for this kind of situation? Essentially, we are trying to join two database tables where one of the tables is extremely small. Do you think our usual join will be good? Our usual way of join of creating map reduce is a good way, or do you suggest any other approach? Yep. Lloyd, Mike, Josie, Lakshman, Anandita, Sanjay, Vidya, Savna, Lux, Suresh, Richard. Savna is saying in MapReduce we could use distributed cache. Good. Keep going. Okay. All right. All right. Correct. 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 So yes, basically using there is an API provided by Hadoop for using distributed cache. You can use it directly, or even if you are using a streaming kind of a situation, you can basically ship the data file as such using the technique where we have shipped our mapper and reducer. In the same way, you can ship any file to all the nodes and then read that file. Okay. Now, so yes, so Sarna's approach is correct. Basically, what we will do is the second file which has got hundreds of records, we just take it to every node, ship it to everywhere, okay, and there we on the map side itself we we load the second file into the memory, and on the map side itself we translate the data from the in the join in the while going through record by record, we translate the country into the country code, right? So that's one good approach of getting it done on the map side. Now, pig does not provide you directly that way. Okay, it would, or you can say it would not try to detect automatically to when to use this kind of join or when to use other kind of join. And what are we saving here? With this kind of approach, we're doing everything on the map side. We don't need a reduce phase for this. We do not need the reduce phase for this. That means we don't have to sort the data, and hence it will be fairly faster. The only time will go in is in transferring, is reading the data from the disk and translating them and then saving them to HDFS. Okay, reading the data from HDFS and then running the mapper code and saving it to disk. That will be the time that will be consumed. Okay, to get the same thing done, you can do a very simple thing. All you need to do is while joining, mark the second table as using replicated. Okay, while joining persons with CC country code. So while joining these two tables, persons and CC, mark the CC with using replicated. Okay, that's it. You don't have to do any other thing. Rest of the join will remain as such. Just mark the second table as using replicated. Okay. All right. So, Sarna, you were asking about some things which could MapReduce could not do. Basically, there are very clever things which have been done in Pig Latin, which otherwise you will have to code it by yourself. All right. So, this is one of the few things which Pig comes up with, which you can utilize. So, replicated join is are quite useful when one of the file is very small and it's easy to do the joining in the map side itself without involving any sorting and any reduce. All right. Sometimes you are dealing with skewed data. And what does it mean by skewed data? All right. What does it mean by skewed data? Skewed data means there are too many values for some keys and there are too few values for some keys. And when I say the ratio between too few and too many should be more than 100, more than something like 10,000. Okay, 100,000 or 10,000. So if that is the ratio of the minority and majority, then we call it data is heavily skewed. Okay, so the ratio between some countries people name will be of 10,000, that way, because if you think about Ireland and think about India, the total number of people living on a country will have a very big difference. Okay, so therefore that kind of data might become skewed. All right. So so we can say that the the name of the country statistics are skewed by country name, because for some country there are too many people and for some country there are too few people. Okay, so when you are joining such a data set which has got this kind of variance, then you got a skewed data. And if you remember our similar problem, when we were talking about word count or we were talking about other problems, we were thinking about The words like the, of, is, am, are, for them, for these common words, the number of values will be too many, right? These common words occur too frequently, and therefore they might become the disaster in joining. While joining such kind of data which is skewed on the key on which we are joining, then the normal joins might become disaster and overflow your reduce. Okay, in those cases you could simply say using skewed. Okay, and pig will take care of joining the two data set even if there is a even if the data is heavily skewed. All right. Next is sorting the sorted data. We have already discussed that sorting the sorted data takes equal amount of time as sorting the unsorted data, right? Therefore, sometimes when you're joining the two data set which already have sorted data by the same key on which we are joining, we can say using merge. Okay, that will make our process really fast. That will make our process really fast because it doesn't have to sort the data again. All right, now there are two questions. One is Sarvnas, which is, he says that what is the limitation on small file? His question was related to the previous screen, so previous topic. Yeah. So the limitation here is any small file whose data can comfortably fit on all of your data nodes. Okay, then it's okay. So Sanjay's question is, in these kind of scenarios where we are trying to compute join on skewed data and we do not say skewed, what will happen? Actually, our reducers will overflow and pig might give you an error saying the data node has exceeded the memory. Okay. I mean, the node manager, or you can say application master, will suffer the memory problems. All right. Next is that it is a common practice of joining two tables on the same key and then grouping the data by the same key. So you are joining on the same key and the grouping by the same column. Then it makes sense to use co-group instead of joining and then grouping. Okay. If you want to do grouping and then joining, or joining and the grouping, you need to basically use co-group. Okay, because co-group makes it possible to have only sorting once. If you are doing it by yourself and trying to first join the two data set on a particular key, okay, if you're trying to join two data set on a particular key, that means there'll be one sorting involved on that map reduce phase. And next time once we have joined the two records and then we group it again, then again the sorting will be involved. So to avoid those kind of problems, we could simply use co-group. Okay, or we could also use joining with merge, the one which we just discussed in the previous screen. We could use this after grouping. All right. So you can see clearly what's happening here: person, animal, and name animal. And what we are trying to do is we are trying to join these two and then sort the data by a particular column called animal. Okay? So that all records for cat we want to bring together, and all records for dog and fish. All right. So that was co-group. Next is union. Okay. Union is nothing but concatenation of two data set. It's equivalent of saying cat file 1 and cat file 2. Okay. If we are on this, here, let me just exit from here. So let's say we have cat try.txt, right? This is one. Okay. And there is another trial.txt. Okay. Now let's say we want to concatenate these two files. We can simply say cat trial and try.txt. Okay, so it basically combined the two files together. You see that? Same is the case with union. Okay, union basically makes it possible to join two data set by appending to each other. We can simply say A equals to load some file, B equals to load some other file, and then we can simply say C equals to union A comma B. Okay, which means all the records from A, all the records from B put together become C. Okay, now the union gives us one more facility. That facility is matching the columns. So while putting the data, it can help you put the data in a proper columns by saying union on schema. The next screen will help you understand what does it mean. Let's say there were two data sets, A and B. A had two columns X and Y, and B had two columns Z and X. And when you simply concatenate these two records, okay, so they basically get just concatenated like this. That's a normal union. Okay, and if you have to do a union on schema, if you do union schema, what would happen is there'll be three columns instead of two, called X, Y, and Z. Under X, all the values of X will come, which is B12, B22, and A11, A21. While under Y, there will be blanks for B12 and B22, and for A11 and A21, A11 and A21, okay, A11 and A21, we will have A21 and A22. Okay. Now for case of Z, we will have all the values for X here, while there will be blanks in the same dataset. Okay. I hope the on union on schema is clear to everyone. Now Savna's question is, can Y and Z be of different data type? Okay, so if here these X and Y are of this X and this X are of different data type, it will keep them in a different column. All right. So let's go through this example once more. Probably this is the best way to understand on schema. If you do a normal union, it basically takes all the records from this and append with the second one. While if you do union on schema, it will figure out what are the total number of columns that are there in both the data sets A and B. What are those columns? X, Y, and Z and X. So which means X is existing on both the sides, and there are two more columns y and z. So it creates three columns x, y, and z. Now it fits in the records from first data set, which is B12, B22, okay, and it has got a column called z, A2, A11, and B21. So it tries to fit the data set by leaving the values for column number y, column name y as blank, and same, and afterwards it picks the data set called A and then tries to fit its value on schema. Okay, it's basically first created a sort of an schema and then is trying to fit the records based on that. Okay, while appending is basically trying to fit the data into appropriate columns. Make sense now, Sanjay? Is it clear? No. So it display the columns in this matrix? No, it will display x comma y comma z and then the values. Okay, if I have some data already, I could show you. So let me just see if I have something. All right, there is looks like there is something. All right, so these are the two data set. Let me try to load them. Okay, and let me just try to put data here and data here. Okay, let's just see. All right, so we can if we have a look at a will contain x and y, and if we try to say c equals to on schema, okay, here, and then dumpty. Yes, that's correct, Vidya. Okay, while this is coming, let me try to answer a couple of questions. Vidya's question is, so the common column is formed based on column name declared in load statement. That's correct. All right. Now you can see that, Sanjay, that the column in the between have been left blank here. You see, this is blank, and then here the last one is blank. I've just tried to represent it in a nice matrix format. Is it clear now? Union on schema, everyone? Great. Right. I can basically copy paste this here. All right. Makes sense to you? Now, question to all of you is, if we have A and B, let's try to do join A comma B. It says error. Okay, did I make a mistake? So if we say join A comma B, what do you think the result would be? And all right, let me ask you another way. What is the result in RDBMS if you say join A comma B? All right. The thing is that when we discussed about join, because join heavily deals with MapReduce, therefore it's not possible to use the normal join without a column key. Okay, otherwise it will give an error. That's where we came up with an idea of something called cross product. Okay, so if you have to find all the possible records, you can say cross, we could say cross A comma B. Okay, where is the data set? Or let's try to say A join B. It gives an error. It says expecting by, while in case of cross, it accepts it. And let's see what happens. It will generate all possible combinations of the records from both the sides. It doesn't matter. Yep. All right. So we can basically generate the all possible permutations of daily and divs. So for all rows, for each row in daily, every row of divs will be combined together. So if daily has got 10 rows and divs has got 5 rows, the total number of records in the output will be 50, 10 into 5. Because for each of the records in daily, we are combining it together with divs and giving the result. Now you can see here there are four records, 2 into 2. So for each record from A, we have combined it with each record of B. You can see that, and so on. All right, that's how the cross product work. All right, now most of the time pig will be used for generating the various kinds of reports, and hence it's a common practice to pass arguments to the reports. It wouldn't make sense for in production to keep changing the pig script. Okay, instead passing an argument is a better point. If you are using any of the BI tools, you would be very familiar with the parameter substitution. Similar way, you can do it in the pig as well. By defining a variable like this, you could say $date and then pass date in the argument while executing the script by saying pig minus p date equals to this, and that date will be in here. Okay, will be used here. So every time you execute daily.pig, you can give different date and get the data filtered by that particular date. Now sometimes there could be many variables that need to be substituted every time. So you can keep these parameters file in a different, you can keep all the parameters in a different file and use that parameters file in the argument by saying minus param file. All right. Now, sometimes we want to split a data set into various legs. Okay. Say for example, there is something called W logs, which is web logs. We are loading it, and out of this we want to create three data set: April 01, April 02, and April 03. Okay. Now, after we have created these three data sets individually, we can start with group by, filter by, this, that, all kind of operation we can do on individual data sets, right? This makes our life easier if we are trying to have different strategies or different analytics for different parts of the data. Okay. And and also note that it is not really like a standard split where if one record goes into left leg it won't go into the right leg. That's not the case here. Also, it is not here one record might be completely ignored. Okay. So it's more like taking a record, copying it into multiple records, multiple data sets. And that's what is happening here. So a single record can go into multiple legs. These are the legs, okay? And a record could also be dropped out. All right. Also, these things will be very much optimized in case you are splitting the data set. In case of if you have multiple data splits happening like this one, there are chances that pig will optimize it such that in a single map multiple splits would be there. Single map there will be processing from many different statements, and similarly in a reduce there might be processing from different data sets. Okay. So pig tries to combine multiple groups and filters into one, and also create multiple map jobs depending on what we are trying to do, right? Let's take a break here and come back in 10 minutes. All right, 10 minutes is okay for all. Let's come back in 10 minutes. Back by say 10:15 p.m. IST. All right. Hi, should we start now? Is everyone back? Should we start now? All right, Suresh is here. Great. All right. Now, here is something which you were asking earlier. Probably we have already discussed it. In Pig Latin, user describes how to process the data. In case of SQL, you basically ask a single question that needs to be answered. In Pig Latin, it's generally long series of data operation. SQL is around just one query. Again, Pig Latin has been designed bottom up for parallel or distributed computing, while SQL has been designed for RDBMS, and we are trying to fit it with the distributedness. Pig Latin targets multiple data operations and parallel processing, and SQL is good for multiple data operations. The query gets complex. Okay, in case of SQL, if there are multiple data operations, the query easily gets complex, and we might end up using lot of temporary tables, lot of set based operations. Okay, now the last point is probably the most important one, where we basically Pig Latin is good for handling the incomplete or inconsistent schema, while SQL requires well formatted data. All right. For more details, you can have a look at the pig documentation online, and this is probably the best way to learn pig. All right, thank you very much. Let's move on to the next session, which is Hive. All right, good. All right, any questions before we move on to Hive? No questions? All right, good. I hope the session is recorded. Yeah. All right, so Hadoop is great, but the question arises that how would you move the existing infrastructure and existing user base. There are so many people who know SQL as of today, since SQL has been in production since 1970s. Okay, so and probably as database is one common thing other than the operating system, which is there in almost every organization. Now, how do you it's very difficult to move the existing user base and existing infrastructure. When I say existing infrastructure, it means both the things. First, it means lot of data is there and lot of queries are there, reports are there, and stored procedures are there. Lot of business logic is inside the SQL. All right. Therefore, it doesn't make any practical sense to target that we will move the existing all users onto Hadoop. That's almost impossible. Therefore, the adoption of Hadoop or solving the problem with the big data will be a big problem if you have existing big legacy code, right? And that's where Hive comes into play. That's where Hive comes into play. And the other problem with MapReduce is that since MapReduce was is fairly difficult for even the developers, it takes a considerable amount of rethinking the way we have been doing things, and a lot of repetitive logic is there for say joining the data, grouping the data. A lot of repetitive logic arises, and that's where the that's where the Hive comes into play. All right. So the value proposition of Hive is most suited for data warehouses. Is relate and when you have to analyze the relatively static data and you do not require fast response, okay, and at that point of time Hive might be quite useful, and it's also very useful to port existing projects. It provides SQL dialect, which is a new SQL dialect called HiveQL, which is very similar to Oracle, and it also tries to absorb the common features from all the databases, so that the overall objective is it should be very easy to migrate any of the existing SQL scripts onto the Hive, onto the Apache Hive. It should be very, very straightforward and simple. All right. Now, it has got, unlike Pig, every time you run Pig, you will have to again define your data set. My data set div equals to load my file and all that, right? So that's not persisted, and that's the reason it doesn't require, Pig does not require any server side component or any other component other than the Pig client, because it doesn't maintain any state. But in case of Hive, it maintains the state of all the data tables you create, and thereby it requires metastore, something called metastore, where it will store all the tables you define. The way we were defining divs equals to load some file, you don't have to define it again. It is persisted onto the server in case of Hive. Basically, in case of Hive, when you create a table or create a database or create a kind of view, all of those information is stored on the server side in something called metastore. And what is a metastore? Metastore is nothing but a layer on top of existing databases. Right now we have configured metastore as our MySQL server, which is running on Hadoop 1. Okay. It allows you to query HDFS files and also allows you to query HBase. Okay, so where basically what we understood from this slide is Hive is good if you have to query the static data. If you have to query the static data, you can use Hive. All right. The limitations with respect to Hive is it does not provide you the record insertion, creation, or updation. It only allows you to query the data. Or you can generate the full data set. You can say insert into a fresh new table and select from one data set. That you can do easily. Basically, the behavior of Hive is similar to the way you modify the big files, right? You can create a new file, but if you're modifying a file, it's equivalent to creating a fresh file and updating, deleting the older one. So the behavior of Hive is like that. It's not great for online transaction processing. Reason being that there is a high latency because Hadoop being batch oriented, there is always a setup overhead for every MapReduce job. Okay, so this Hive is great in case of data warehouse. It's good for churning the large data set which is maintained and mined. If you want to mine, Ravikant is asking, is it similar to SSIS? I have not used SSIS, but I'll like to have a look at it. SQL server-side integration service component of Microsoft. Um, Not much, not much. I need to understand exactly does it mean by this. It's a full-fledged SQL query which gets converted into your MapReduces. Okay. All right. So here, whenever if you did do not find it comfortable with the writing MapReduce, you can either use Pig or you can either use Hive. Both are almost interchangeable. Okay. That's correct, Sanjay. Sanjay's question is, so can we have an existing data warehouse in Teradata and create a Hive meta store and query it? Yes, you can do that. I mean, you don't have to create a Hive meta store. Okay. Hive meta store only contains the definition of tables. The data is always in HDFS. Data is doesn't go into meta store. All right. Let's just go over the architecture quickly here. So as you can see, the bottom part is Hadoop. Although the diagram says job tracker name node is no longer like that. We have now application master and resource manager. Okay. So the bottom part says that there is Hadoop, there is Yarn, and there is HDFS. So every query you do in Hive that gets converted by the driver, that gets compiled by the driver, and MapReduces are executed on Hadoop. Okay, so this driver converts every query into MapReduces by the help of Metastore. Okay, and how can you ask queries to Hive? You can either use command line, or you can use Hive web interface, which is provided by Hive server. As well as there is something called a thrift server. A thrift server is a generic service platform which you can use if you want to make your application accessible from all kind of libraries. If you want your APIs to be available for all programming language, you can start using thrift server. Thrift server comes from Twitter and is very popular when it comes to creating the API for almost all the programming language and having a service architecture. Okay. If you have service oriented architecture, you generally end up with thrift server if you are looking for high throughput service. Okay. Now, thrift service can be accessed through JDBC or ODBC. It provides that interface. And all of this can either be used from a product, complete web application like Hue or Cubole or Karma Sphere and others. There are many such similar tools. All right. This is the example of how do you do the word count using SQL. Okay. Here what we are saying is first we copy the file from one location to another just for this purpose so that it doesn't delete our files. Then we load data from this location into a table called docs. And when we load this, it'll have only one column and that column will contain the line. All right. So create table word counts as select this from count, select this as count from the, and here the most important part is this explode. Explode says split the file by line, which means it will become an array, and then explode will convert the array into individual records. And after that, we do the group by, and then we do the word count. So Sanjay's question is, if we are using legacy database, where will they fit the Hive in architecture diagram? Okay, that is a question from Sanjay. Now, so keep in mind that Hive helps you query the systems like Hadoop, HBase, and others, which support the MapReduce. So HBase supports the MapReduce, and HDFS supports the MapReduce. So it's good for churning that data. Okay. So generally, whatever data systems you already have in place, you when you move on to Hadoop, you basically take the existing data, move that to HDFS and HBase, and then you start using tools like Hive or any of these. Okay. So all I'm trying to say is here Hive will not be talking directly to talking directly to any other system than Hadoop. While if your system say you have got query BI tools, say there are developers who are creating BI tools, they will be talking to the JDBC interface. Their queries will be coming to JDBC interface, and then via thrift server they will get executed by the driver, and the driver will convert into MapReduce. The result will be given back to the driver, and then driver gives it back through the JDBC to the end user. Okay. So mostly if you have got your existing tools, they are going to connect to JDBC and talk to the driver. All right. All right. So this is an example of Hive word count example. So let's try to get started. So any of Hadoop 1, Hadoop 2, Hadoop 3, Hadoop 4, you can simply SSH and you will get the access to Hive. All right. We already have this opened. We can simply say Hive here and it will launch the command prompt. Although you can use Hue, you can use Hue, but it's a little slower. That's why I don't prefer it. Hadoop 17. Lakshman's question is, do we use Beeline or Hive console? Anything is okay. Anything is okay for this. But these days, some people have started using Beeline, and that seems to be good. All right. So here you can also go to say Hive and then start executing your queries. All right. Let's just stick to our terminal. This is our terminal. And let's try to see if it is working or not. This is the quickest way to check if things are working or not. Okay. Let's say, all right, we are able to create table, we are able to select from table, and we are able to delete from table, delete the table. Okay, so that means it's working fine. All right. The other thing is you can either execute Hive the way we are right now running in interactive shell mode, or we can, if you want to just execute one particular command and then exit Hive, then we can also use this kind of argument. We can say Hive E and provide this. If we have already written all the commands, SQL commands or SQL queries into a file and we want to execute the full script in a single shot, then we can say hive -f and that file name. All right. All right. So next question is, can this Hive prompt can run Hadoop DFS commands? All right. Just like Pig did. Just like Pig, it also runs all the HDFS commands. You can see that. And if you want to load an external Hive script, you can also say source and provide the SQL script or Hive QL script, whatever you want to call them. The commands start with double dash, and you can set the environment variable using any of these ways. Okay. Also, you can execute the local commands like this. You can see that I was able to execute local ls by putting exclamation ls and semicolon. See that? So that's how you can execute the local shell commands. All right. So Vidya is having some audio problem. Are you having intermediate intermittent audio problem. Okay, Ravikant is not facing any problem. Sarvana is not facing any problem. Okay, all right. So others are not facing. So probably you can try disconnecting once and then joining. All right, and that should generally solve the problem. All right. All right. So with respect to data types, the most important thing to remember is the data types in case of Hive are increasing every day. And the objective of data types in Hive is to be compatible with almost all the query language. Okay. So here are the data types. So there are one called numeric types. Under numeric types, you see there are so many tiny int, small int, big int, float, double, decimal, right? And then there are some miscellaneous types called boolean and binary. String types are there, and you can see that earlier there was only string, now there are varchar, and after .113 version, after .13 version, it has got varchar and char, and then we have datetime and timestamp. All right. And then other than primitive types, there are complex data types such as arrays. Okay. You can define your array by using a keyword called array, like the way we have defined here. Okay. And you can also have a field called of type map, struct, union, and so on. Okay. So union is a data type in which at one time you can have various different types of data. Okay, so for one column it could be integer, for another column it could be boolean, for another column it could be string. Okay, but not all three at the same time. So for example, if you are having some sort of an authentication system in which sometimes the ID comes from the Facebook, sometimes the ID comes from Google, sometimes the ID is internal. So in some cases the ID might be integer and some cases the ID might be string. But there cannot be two IDs at a time. All right. So which means that is a good the so this ID would be a great way to use the union data type because the memory in both the data types are same. All right. Now inside Hive, you can create your own database to keep your tables separate from others. So per project, you generally like to create your own databases. We can have a look at it. We can say show databases. These are the databases already existing. All right. How come there are so many? All right. They are from all the users. Okay. Show databases. Okay, you can create your own database saying say Hadoop 17 SG. Okay, and use Hadoop 17 SG. That's how now you can start creating tables in here, you can start create table X with what was the data type, with column as integer. Okay, now you can say show tables and see what happened to our, you can see there is a X table. You can say select star from X. All right, now that's how you can create a database and use it. Now we just showed you that you can have a look at the table by saying show table and select star from table to get the records from a table. And you can also say things like describe formatted and X. Let me correct the spelling. Describe formatted and X. You can see it contains all the information about this particular table. It says it's stored in a database, this one, and owner is Hadoop 17, and there are so many, you see, there are so many uh, information available to you. We'll go into these details as we go forward. All right. So when we are creating tables in Hive, there are essentially two basic kinds of tables. One is called managed tables, other is called external tables. Not much of a difference. Okay, the only difference between managed and external is if you drop a managed table, it will delete the data. If you drop an external table, it would not delete the data. That's the only difference between managed tables and external tables. All right. Now Sanjay's question is, where is this table being created with the data? So right now, as we go forward, this will be very clear to you. So whenever we are creating any table, the table information, like what columns it has, what is the name of table, and what is the data type of various columns, all of this information goes into metastore, which is MySQL, while the actual data will be in HDFS. All right. So this is what I was telling you. So all of the information about the table goes into the metadata, goes into the metastore. Okay, you can have a look at it. Let me just log in into. Let me SSH to another account, or let's say let me SSH into, yeah, let me SSH into another account, the account which has bigger proposition, bigger permissions. Okay, all right. So here, if you say show tables, there is no database selected. Let me just show databases. This is please keep in mind that we are right now talking to MySQL. Okay, so here do you see something called Hive? Okay, now if you say show tables, you will see TBLS. There are many tables in this particular database, and one of them is select star from tables and limit 10. Okay, you can see that every table which has been created is actually here. Okay, it only contains the information about what table is it. It doesn't contain any data. Lakshman's question is good, very good question, and I'm happy that you asked. So when we create a managed table for a file in HDFS, does Hive create its own version of data in HDFS? No. It just uses the one which is at the existing location or creates new file at that location. Okay? Let's try to first load the data, and that'll make everything clear. Let's try to create something called NYSE daily. It has got exchange symbol, YMD, price open, high, low, close, volume, and all of this data. And this is located in NYSE daily. There is a folder at this place. All right. Let's just say, or let's try to do this. Okay. Let's try to. What does it say? It says that you don't have access permission on this particular folder. Okay, you don't have access to write the data. All right. So let's instead of that, we will try to just create this into our folder. Let's try to create it into our folder, which is here, like ouch. Hadoop 17. All right. So here we are. All right. So yeah, let's try to see what is there in Hadoop FS. All right. And what would be the folder there? What would be the folder locations? So let's just try to go into Hive. So there's already some table existing. Let's give it some other name. All right. Let's give it some other name. What do you want to call it? Yeah, let's just call it 29.7. Now it says that relative path in absolute URL is not something accepted. All right, let's just try to put it in our folder. Okay. All right. Now here at this place, there is nothing right now. If we try to say select star from this location, there is nothing right now. It says nothing. So if we put some file over there in this folder, okay, if we put some file in this folder, let's just find out this here. this is empty right now. Okay, so we'll just keep that in mind and go to top level, and let's say this file. Let's copy this file into that location. Okay, so let's see if it has come. So as soon as we created a table, it created a folder with this name. Now, if we put the data in this folder, it will start to query it. Otherwise, if we load data into this table, it will automatically create file in this location. That is the meaning of the location. Select star. Now let's try to do it again. Now you can see that. All right. So all of this data is coming from our HDFS. It has nothing to do with the meta store. Only this information, like somebody tried to create a table called this, whose location was at this position. That's the only information that goes into metastore. Okay. Now if we load some data into this particular table, it will create one more file here, and when we drop this table, this whole folder gets deleted. All right. Now if you see this, now we created this particular table, and we can do things like select what were the column names, by the way? Let me just say exchange, and let's say average of not average, let's say symbol here. So I'm trying to compute the average value of each symbol. Okay, let's say I'm trying to compute the average price open. From this, group by symbol 1. Now you can see that it is again going to MapReduce. It is launching a MapReduce job internally, although we have run the SQL command. We have said select symbol average of this much from this table which we just created, and put some data by copying the file, and we are saying group by this. And you can also see the tracking URL. We can go to this tracking URL and we can start working. Now you can see it has done a very good job of computing the average value of each of the symbols without any problems at all. Now once we have this kind of control, now we don't have to worry about writing MapReduce at all. We can simply keep on loading data into tables and get to work. All right. So it's very straightforward, as in, if the data is already existing and you create a table with that location in mind, then the table will already have data. That also means that you could create multiple tables having the same location. Multiple tables having the same location, meaning all these tables will be reading from the same files. Or at the later point of time, you can load the data into table using load something. I will talk about it. Or you could simply copy the file into the folder which has been created because of creating this table. Okay, so I can show you, let's say there is this folder, right? There is this folder. We will just drop the table. Okay, we will just drop this table called NYSE. This, we could say drop table. All right, now this folder will be no longer, it'll give an error. It's saying cannot access that folder. You see that? It's no longer there. But if I create one folder already here, I say new directory with that name, and put some data in that directory. This is very important. Probably this will clear a lot of doubts. Okay, so I just created a directory and go to say go to a folder called data and bring the data from the data folder. Let's say this file. Okay, let's say this file, and I mentioned that I want to copy this file in this location. Okay, and let's just go to that location. Now see, we just copied this file. This is a folder, and now we are going to create this particular table. Okay, it doesn't give an error saying the table, this location already exists and so on. As long as the table is unique, it's okay. So select star from this. You can see that. Yes. So Sandeep's question is, can I copy multiple files under this? Yes. Okay. So if you copy multiple files under this folder, that means it will read data from all the files. Okay. Whenever you are running any query, it will basically concatenate the two files and give you the results. Now there is a question from Sanjay. Question is it two level of security now at table and five level? Yeah, you can say it's not two level. Basically, it's kind of the right access permission. So when you are creating a table, the table is the in table information is being created in Metastore, right? So you would require, you should be able to create the table in Metastore, which everybody is able to, as long as the table is not existing. Okay. Second is that whatever table location you are creating, if your table is managed, then that table location should be writable. Your Hive should be able to write to that location. All right. That was the second problem. Sounds good to everyone? Everybody is okay so far, whatever we have done so far? We have tried to create a table and then copy the file into the tables folder. And in the second attempt, we had already a folder and then we have copied data into it. All right. Now keep in mind that if I delete this table which we just created, the folder we had created for this table will also go away. It will disappear. Okay, so keep that in mind. Although Hive did not create that folder, still Hive will delete that folder. Now let's load the data. If I have to load the data, okay, So let's say I want to copy the local data into Hive. Let's just delete this. Okay. So if I now go here, oh, something has wrong. Hadoop 17 and the password is, alright. Have you guys tried Control Shift V in this terminal? Alright. So keep in mind that other than the usual table description, there are two extra information here. One is called the row format. Okay, this basically says that when Hive will be reading the data, how should it interpret the input data? It says that the fields are terminated by /t and by default the records are terminated by /n. Okay, because our file is tab separated. Now let's try to load the data into Hive using load data. Okay, but we don't have a file right now, so we will have to copy the data first to locally and then we'll try to do that. So where are we? Let's just get out of this. Okay, is the prompt visible to you? Okay, Sarvana says that Control Shift V is pasting to the terminal. Okay, so you can try Control Shift V in case you want to paste here. Alright, let's try to first have a file called NYSE daily. Do I have a file here? Let's say I'm renaming my local file, a local folder. Okay, this is easier for me. So let's just copy some data, copy fs, Hadoop fs, copy to local and /data /ny nyse. What was that file name? File name was nyse daily file. Okay, I want to copy this file to the local folder. It has been copied. Now let's try to load the data into our Hive table. All right, I've started Hive, then we will say load. Okay, and let's say load data local, in path is this, and then we will, so local is a keyword here. When we say local, it tries to load the data from local folder, not from HDFS. So we can say load data local, and I can say asgiri, or I can simply say, what was the table name? Hive daily file, and overwrite into this particular table. Okay, let's see what happens. It says that missing in path. keyword here. So load data local in path. Is that how you have written? In path, yeah. So it's saying copying the data file from the local path to HDFS, and then once it has finished copying it, it has moved the data into our folder for designated for this particular table. Okay, now let's have a look what happened here. Okay, let's go back to home and sort the data by date. I'm sorting the data by date. Go into the folder. You see that it has copied it. If we execute it again, it will make one more copy there. Okay, it's not copying because we are saying overwrite. Okay, we are saying overwrite, that's why it's overwriting other data. If we remove this overwrite from here, it will create one more folder here, one more file here. You see that it is creating more files in that folder. Alright, and all it's doing is it's copying the data from local file to HDFS first and then moving it to the right place. Sounds good? And rest of it is basically you converting SQL into the MapReduce. Okay, you can see what's there inside it. Inside it is tab separated data. This is tab separated data. All right, now if you want to copy the data from from HDFS, then you can, let's just try to copy the data from let's what if I try to do things like this. Hadoop data local in path, and here I say data. It says although, so what it did was it did something interesting. Okay, so whenever we are loading the data from HDFS, so see this. Whenever we are loading the data from HDFS, when we say without local keyword, so here when we simply said load data, not this, no, not this, yeah, this one, load data in path this into this table, right? It tries to first move the data from that location to this folder's location, and that was not successful. Okay, so there are one thing which we just learned is whenever we are loading data from local folder into our table, it basically copies the data from local to HDFS. But if we are loading the data from HDFS, it moves that file to the tables directory. Okay, and this is a good behavior in a way because it's like it's a default behavior of Hive that whenever you will try to load the data from HDFS, it will move that file into your table. Otherwise it will try to, you know, if it could not move, it will not it will give you error. It will not never try to copy the data in HDFS. All right, let's try to copy from local. Let's try to copy the data from local. This is the file, right, which we copied to local, and copy it to a folder called as Giri in HDFS. It has successfully copied it. Now we're going back to Hive. All right. Now at this point, let's try to load the data from the file which we have just copied. Okay. Let's first see if it is there or not. Or we could simply say DFS. Yeah, the file is there. Good. Now let's try to load the data from there to our table. What was the name of table? 29th September. What was the name of table? I think it was something to do with this one. Now it has moved that file from that location into our folder. You can check this. Now it will show no file. There is no such file or directory. So it has basically moved whatever we asked to this folder. Okay. So what we learned just now, whenever we are loading data from local file, the data gets copied. But if you are loading the data from HDFS, the data get moved. All right. This is a very important piece of information because that's probably the most common cause of confusion. All right. If you do not say in your table description that your fields are terminated by /t, by default, a non-readable control character called control A will be used, will be considered for parsing the data. So it will think that data is separated by control A. All right. So was the table, Sanjay's question is, was the table existing in the case or can it create the table on the fly? It cannot create table on the fly. You will have to create upfront. Okay, only then you will be able to load the data. All right. Once you have created your table, something of this sort, you can say things like this. You can start having these kind of queries. Okay. You can simply say, all right, where, okay, it's symbol one actually. All right, so you can quickly, the way we did group by, you can also execute similar other query easily. Also, if you do not provide here the way we have provided the location of the table, if we do not provide that location, automatically a folder in apps hive warehouse will be created. Okay. All right. If you want to save data into your local folder, now you can see all the CMC records. It is showing only the CMC. If you want to save the data from the table, if you want to save the data from table onto the local file, you can simply say things like this. Okay, you can simply say insert into this folder, and let's say 29 September, and we want to save the data from that query. It says invalid table alias. That is right. We have to say symbol 1. Cannot recognize input near equal. Symbol 1. Yeah. It will create the table and store the data. Alright. And if you want to save the data in HDFS, you can use this kind of syntax. Instead, you just have to omit the local keyword here. Alright. So we are able to store the data easily. Next is partitions. So out of your table, you can create partitions. Right now, there was no partition in our table. The all of the files in the folder of the table were considered as the data storage. Okay, but you can create the partition over your tables to avoid the full scan. So only the tables that belong to that particular partition, okay, all the files that belong to that particular partition of the table, only those files will get scanned. Okay, when you say select star from this table and where column value is equal to this, only those tables where the column value is that much, only those files where the column value is CMC, only those files will get queried. So this is kind of a way to do the partial scan of the data. Okay, so right now there are no indexes in case of Hive as of now. I think they have indexes in the next versions. So okay, so basically the data gets stored in different files based on various combination of columns. You will see that. And you have to define the partition using partition by keyword in create table itself, and partition can happen on multiple columns. You can also add partition at later point of time. Let's have a look at the partitions. So let's say there are two tables. One is the amp and other is the amp1. Okay, let me just copy these tables into our folder because it is going to let's just bring it to our local folder. So there are these two files. Not this one. Where is my folder? Yeah. Alright, I've copied the data. I've copied both of these files. Let's have a look at what is there inside those files. Okay. One file will contain this as Sandeep 10 BTech, Shravani 9 MA, and we are saying we're creating a table called employees. Okay, where the we are defining only three columns: name, salary, and degree. And we are partitioning it by an extra column called qualification. Okay, that's the partitioning criteria, and that will start behaving like a column. And also we are saying that our fields are comma separated. All right, so we are saying use, what was that, Hadoop 17 SG, right? And then we are saying create this table. We can see show tables. Yeah, it's there. And under SG there is SGIRI, there will be DFS LS SGIRI. All right, the table is there. So we can have a look. DFS minus cat and the amp. You can see it's working fine. The data is there, and the amp1 is having this data. All right, so there are these two partitions. Let's try to create load that data into our employees. Also, let's also have a look at what's going on with our employees table. It shows us, when we say describe formatted employees, it shows us that the managed table, it's a managed table. Second, the data is located at this particular location. You see that? The data is located at this particular location. All right. So right now there is nothing inside this. Okay. As we keep on loading data, the files will start appearing. Now we are saying load data in path the amp into table. This is something we want to change. Why? Because our data is in not local. It is in SGIRI, I think. It is in SGIRI folder. All right, let's try if it works. All right, now first file has been copied. Okay, so first file has been copied. Let's have a look. Yeah, so first file, when it was copied, what exactly has happened? We are saying we are saying load data in this path into the table called employees for a partition called qualification equals 1. Meaning we are saying load our data but only in a partition called qualification equals to 1. Okay, and internally what exactly is it doing for us is it's creating a folder called qualification 1, and under that it's putting our file. Okay, so now let's go ahead and create one more. Yeah, this one. There we are saying qualification equals to 2 and the data is coming from another file. All right, now let's have a look at the file structure, as well as let's have a look at what happens when we query the data. Now you see, there is this table called employees whose data is under 2 folder, qualification equals to 1, qualification equals to 2. When we say select star from employees where qualification equals to 1, only these files which are under this folder gets queried. If we say select star from employees where qualification equals to 2, then the data under this second folder gets queried. Okay, let's try to do this. We'll say select star from employees. Now you see there are four columns. The fourth column is designated for the qualification, that criteria on which we have created multiple partitions. Okay? So when we say select star from employees where what is the fourth column name? Qualification equals to 2. Okay? So it queries the second partition only. And when we say things like less than 1, then also it uses that smartness to query the data. So although the fourth column looks like proper column, but the fourth column is actually not a column. It's just a partition. All right, makes sense to you? All right. So rest of the statements like data definition language, you can alter a table, change the column name to something else. You can alter a table, change the column data type to something else, and you can add more columns to the table. You can drop a partition at later point of time. That will basically delete a folder. If we are saying alter table, delete a particular partition, you can do that. All right. Now, similar to the managed tables, there is something called external table. In case of external table, we can decide, we can query the data which is external to us. All right, we can create external tables which query the data which is there in a read-only format. So if we try to create something of this sort, okay, let's just see. I'm actually curious. Yeah. Now, do you see that? Here, this table was read only. This folder is a read only. Still, we were able to create an external table. Okay. But if you try to create an internal table, it will give you an error saying the data is read only. Let's try to create a managed table. Okay. This is managed table. All right. Oh, it actually created. Select star from my stocks. Interesting. What was wrong earlier? There, okay. Probably there was a file with that name, like this one. All right. Yeah, that's correct. Earlier the file name was wrong. All right. That's pretty much for today. Let's meet tomorrow and continue our discussion on Hive. And we will also deep dive into HBase and NoSQL tomorrow. Yeah, I had put consciously, I have removed external to just to test. Okay. The only difference between managed and external table is when you drop an external table, there is no I mean, the data doesn't get deleted in case of external. All right. We could also create external table from S3 and other data sources. All right. Good night. Have a great day. See you tomorrow. Bye bye. Thank you, Joshi. Thank you, Sanjay. Thank you, Sarvana. Thank you, Lakshman. Bye bye. Have a great day. Good night.